and because I want to ask you to check one question. So I let you review web caching. So web caching, right now, I just get back to the pages here. And later, I just allow you to go through quickly. And maybe I don't want to mention too much. So we have web caches. And web cache is also known as proxy server. And for web caching, in fact, I want to use web caching. About this, reduce response time, and how web caching can reduce response time for the object. I just draw your attention to think about these. And also, it can reduce traffic. In particular, traffic going through the access link. As for the others, I think you can check it for yourself, but I emphasize the two, and so that you can have the image and later you can know how to have the answer to some problems. And we then have some example. This is the first example, and the first example that we have the final calculation about response time. We will have a few minutes for the first case if we have the current scenario. And of course, I change the label to millisecond as well. So this is original example. If nothing else, just use the simple architecture. And next one, we want to change it, and we don't want to use cache, but we have the high bandwidth. If we have a high bandwidth, and then we have the scale 2 seconds, and finally it's the case caching here, and through the calculation, and we assume non-zero cache hit rate, and we have the calculation. I think you can refresh how to have the calculation. Well, if we know something like this, finally we have the time, the response time lower than 2 seconds. Lower than 2 seconds, and you can have the two cases. Case 1, hit it. So hit it, you can reduce. And another one, maybe not hit. And about this, and there you have 3 question marks here. Reduce the response time. Well, that's why I already know the answer, but this time I just want to check you understand all this or not. Well, up to now, I think I go through the pages here, and it serves as the review before you answer the question. Well, we have the question. All right, next one, let us check DNS. And likewise, DNS, perhaps we can go through quickly if we have some simple idea. And DNS, why we want to have a DNS? It says we have ID. And where you have ID, SSN skill number. Passport, you have number. So of course, you should have ID. And likewise, for internet, we can have a host. Router, same, we have IP to service ID. And also, okay. All right, maybe someone close for me. Okay, so ID. So because of ID, we want to have the mapping. IP and name. So we want to have the mapping. And because of the mapping, and then we want to make sure. Sometimes if we have name, is it possible to look up an IP or something else? So vice versa. Actually, you can change the direction to look up. In fact, if we want to use that one, you can use the command NS lookup, but it's just a command for you for reference. And here, let us continue. We want to know the mapping, and with the mapping, then how to use the following way to allow user to look up. Well, we have a DNS here, DNS domain name system or domain name server. And the DNS centralized database or distributed database. It's distributed database. Why distributed database? And later we can let you know the reason. Well, distributed database, then we can have a hierarchy of name servers. And if we talk about these, it is a app layer protocol. An app layer protocol serving as result. That says we want to know address or name. We need to have the proper translation. All right. Okay, so this is the goal for us. We want to have the proper translation. Well, if we have this, it says, well, we can have the complexity. It says complexity at network edge. Well, that's it. So this is the problem for DNS. Before I continue, let me make sure if indeed you want to have a caption. Caption with a symbol CC. You can turn on your CC. All right. Or maybe, in fact, if you want to check the content by checking the video again, you can use script. By checking the playlist on Teams. So if you want to reshare, you can use playlist, and so that you can check script or caption, and you can have the script. And right now, if I want to check what I taught to you, you can turn on caption, and so that you can see the content for reference. It doesn't mean it's really exact, but at least serving as a reference. Okay, this is a reminder. If necessary, you can turn on caption. Well, let us continue. And DNS service, of course, we have a host name and IP, so we need to have the translation. This is the initial goal. And next goal, you can have editing. Editing actually, the meaning. You don't have a nickname, so we have editing. And editing so that you can have canonical. And later you can know canonical, and we have Alice. So canonical name or Alice name, you can use DNS as well. And also you can have editing for the mail server. Well, you can use DNS at least for the three items. And last one, you can have low distribution. Low distribution, in fact, because of low distribution, actually you have a lot of server. But a lot of server, you just only have one name, and the name mapped to the suitable server. I mean, the server near you. So how to have that one exactly? Same, you can follow DNS to find that IP for you. Well, previously we already know DNS, we need to have the distributed database. And why not centralized why not centralized DNS? It means why we want to use distributed one. The reasons are given here. Single point of failure. That says if you use a single server, and how about failure for that server? And next one, traffic volume. If you just have a single server, all required directed to that server. So you have the centralized server, so you have a lot of traffic there. So we don't want to have that one. And the next one, distance. Far, maybe you can think you want to reach someplace. If you ever heard far away, then it's quite long. And same here, distance. Because of distance, so you don't want to use a single server as well. And the next one, because of single server, you need to take care of maintenance. So because of complexity for maintenance, so we don't want to use centralized DNS as well. Well, here we already have 4 reasons we don't want to use the centralized DNS. So that's why we have the distributed one to achieve DNS. Because of this, if we use centralized, then it doesn't scale. That says if we have small scale and large scale, and we want to allow all the scale can work seamlessly. If we don't have a situation like this, then we call it doesn't scale. That says we don't have the good scalability. Well, because of scalability, the problem of scalability, so we don't want to use the distributed centralized one. So finally, we have distributed one, and also we have a hierarchical database. So it's a distributed hierarchical database. Here, this is the first image. And the first image we call it the first approximation. We can have a root, and then we have here we can call TLD. We can have com, org, edu, and the others. Well, the first one, if we have an architecture like this, kind. Anyone want to send a query, send to root. Okay, and root finally here it's .com, so go to .com, and .com then you can find which one. For example, here it's Amazon, so go to Amazon.com server, and the server here later we can call it's the authoritative name server. Well, this is the first idea. If we have named all the hyperlink like this, www.amazon.com. So how to send a query, send to root first, and then send to com, and send to amazon.com DNS server. And so that the amazon.com DNS server can let know the corresponding, for example, IP for this name. All right, so this is the first image, the first approximation. Why we call it the first image, first approximation? In particular, it's approximation because a structure like this, no, it should like the following structure. But before we talk about that one, we already know the root name server. How many root name server?